In this lesson, we will focus on the common clamping mechanisms of fixtures in Project 3. The purpose of clamping is to press and secure the workpiece onto the positioning elements, ensuring that it does not move under the influence of external forces and maintains its correct position. The clamping device is the component that presses and secures the workpiece within the fixture. During the machining process, the clamping device of the fixture is crucial as it ensures the positional accuracy and stability of the workpiece during machining. Common clamping mechanisms are key components in achieving effective clamping. We will delve into the principles, characteristics, and applications of these common clamping mechanisms, laying a solid foundation for your subsequent study of the design and the use of machine tool fixtures. In the field of machine tool machining, the clamping device of a fixture is a core component for ensuring the machining accuracy and stability of the workpiece. The basic requirements for a clamping device include the principle of no movement of the workpiece, the principle of no deformation of the workpiece, the principle of no vibration of the workpiece, as well as safety, convenience, effort saving, and automation. The clamping device consists of a power source device, clamping elements, and an intermediate force transmission mechanism. Common clamping mechanisms are an important component of the clamping device, each with its own characteristics and applicable scenarios. First, let's introduce the wedge clamping mechanism. The wedge clamping mechanism uses the pressure generated by the movement of the inclined surface of the wedge to clamp the workpiece. Its working principle is based on the mechanical properties of the inclined plane. When a horizontal force, F, is applied to the wedge, it moves upward along the inclined plane, generating a component of force, F, perpendicular to the inclined plane. This component can be used to clamp the workpiece. According to the principle of force decomposition, we can derive this, where alpha is the wedge angle, phi 1 is the friction angle between the wedge and the workpiece, and the phi 2 is the friction angle between the wedge and the fixture body. The wedge clamping mechanism has the advantages of a simple structure and a high force amplification ratio. In some small fixtures, the wedge clamping mechanism can achieve a large clamping force with a relatively small input force. For example, in some small fixtures used in bench fitting assembly, clamping the workpiece can be achieved by tapping the wedge. However, the wedge clamping mechanism has a relatively small clamping stroke and is not very convenient to operate. It usually requires the assistance of other power sources to achieve quick clamping and release. Next, let's look at the screw clamping mechanism. The screw clamping mechanism uses a screw pair to achieve clamping. It is essentially a variation of the wedge clamping mechanism, with the wedge wrapped around the cylinder to form a thread. The screw clamping mechanism has a high force amplification ratio because the lead angle of the thread is usually very small. According to the mechanics of the screw pair, the relationship between the clamping force F, and the tightening torque, M, is given by this, where D2 is the pitch diameter of the thread, lambda is the lead angle of the thread, and phi is the friction angle of the screw pair. The advantages of the screw clamping mechanism include its simple structure, ease of manufacturing, reliable clamping, and a relatively large clamping force and stroke. In actual production, the screw clamping mechanism is widely used. For instance, in some large-scale machining fixtures, screw clamping mechanisms are often used to clamp large workpieces. However, the clamping and release speed of the screw clamping mechanism is relatively slow, resulting in lower efficiency. Another common clamping mechanism is the eccentric clamping mechanism. The eccentric clamping mechanism achieves clamping through the rotation of an eccentric wheel. The working principle of the eccentric wheel is based on the characteristic that its geometric center does not coincide with its rotational center. As the eccentric wheel rotates around its rotational center, its radius changes, thereby generating clamping force. The eccentric clamping mechanism has a relatively small clamping stroke, but the speed of clamping and releasing is very fast. The advantages of the eccentric clamping mechanism include ease of operation and rapid clamping, making it suitable for situations where the required clamping force is not large and the clamping stroke is small. For example, in small fixtures on automated production lines, the eccentric clamping mechanism can quickly clamp and release workpieces, thereby improving production efficiency. However, the clamping force of the eccentric clamping mechanism is unstable and can be easily affected by the wear of the eccentric wheel and the precision of its installation. The Sino-Czech Friendship Factory holds an important position in China's machine tool manufacturing sector. The specialized clamping mechanisms developed by this factory have made significant contributions to the nation's development in some large-scale machine tool equipment. The clamping mechanisms developed by the Sino-Czech Friendship Factory can adapt to complex processing conditions, providing reliable clamping assurance for the machining of large workpieces. These innovative clamping mechanisms highlight the factory's role as a technical leader in serving major national equipment, reflecting the capabilities of China's machine tool manufacturing industry in technological innovation and independent research and development. In practical applications, we need to select the appropriate clamping mechanism based on factors such as the shape and size of the workpiece, processing requirements, and production volume. For example, for workpieces that are regularly shaped and relatively large in size, a screw clamping mechanism might be a better choice. On the other hand, for small, mass-produced workpieces, an eccentric clamping mechanism may better meet the requirements for quick clamping and release. In addition, when designing and using clamping mechanisms, we also need to consider the magnitude, direction, and the point of application of the clamping force. The magnitude of the clamping force should be moderate. It must ensure that the workpiece does not loosen during processing, yet not be so excessive as to cause deformation of the workpiece. The direction of the clamping force should be directed towards the primary reference point to ensure the positioning accuracy of the workpiece. The point of application of the clamping force should be chosen at a part of the workpiece with good rigidity to avoid deformation. At the same time, we must also pay attention to the self-locking performance of the clamping mechanism. For wedge clamping mechanisms and screw clamping mechanisms, it is essential to ensure that they can self-lock in the clamp state to prevent the clamping force from decreasing or disappearing due to vibrations or other reasons during processing. Generally speaking, the wedge angle alpha of the wedge should be smaller than the sum of the two friction angles, phi1 plus phi2, and the lead angle lambda of the screw should be smaller than the friction angle phi of the screw pair to achieve self-locking. In this lesson, we primarily explore the common clamping mechanisms in the clamping devices of the fixture in Project 3 Part 1. We focused on the wedge clamping mechanism, screw clamping mechanism, and the eccentric clamping mechanism. The wedge clamping mechanism uses the principle of the inclined plane to generate clamping force. It has a simple structure but a small stroke. The screw clamping mechanism is a variation of the wedge, offering a high force amplification ratio and reliable clamping, though it operates slowly. The eccentric clamping mechanism achieves clamping through the rotation of an eccentric wheel, providing fast operation, but with unstable clamping force. We also discussed how to select the appropriate clamping mechanism based on different working conditions in practical applications, as well as considerations for clamping force and self-locking during design and use. Additionally, we mentioned the contributions of the specialized clamping mechanisms developed by the Sino-Czech Friendship Factory to national development, highlighting the technical leadership of innovative institutions in serving major national equipment. I hope that through this lesson, everyone has gained a deeper understanding and knowledge of common clamping mechanisms.